In this video, we will learn about the uses or applications of the metals in period 4, specifically the D block metals of period 4. We will investigate their common uses as well as the industrially important compounds of these elements. First, let's remind ourselves which metals we are talking about. On the periodic table, the period 4 metals are potassium, calcium, scandium, titanium, vanadium, chromium, manganese, iron, cobalt, nickel, copper, zinc, and gallium. Let's focus on the period 4 D block metals. These metals are collectively called the first transition series. Although technically zinc is not a transition metal. A transition metal is an element whose atoms have an incomplete D subshell or which can give rise to cations with an incomplete D subshell. Now, why are we studying these metals? Why are they so important? Did you know that most of these metals are used by the human body? But why are they so important to industry? Well, they are all money makers. These metals are so useful in specific applications that they generate a lot of money. For example, those used as catalysts significantly speed up the rate at which chemical substances can be produced. So a manufacturer will make more product in a shorter amount of time. In turn, profit is made quicker. The elements used as catalysts or in catalysts with other elements include scandium, titanium, vanadium, chromium, manganese, iron, cobalt, nickel, copper, and zinc, all of them. Besides decreasing synthesis time, these metals catalyze reactions which produce the base or starting materials for many industrially important processes. Much money is generated because so many reactions initially depend on these metal catalysts. All of these metals are used in alloys. Alloys have many uses in society and are critical to the economy. Some of these metals are useful in batteries. Worldwide, the trend is to find alternative energy sources and energy storage systems. We don't want to rely on fossil fuels for energy. Batteries are a big part of this. Manganese, cobalt, nickel, copper, and zinc are all components of modern batteries. Iron, cobalt, and nickel are used in magnets. We'll see just now how important magnets are in many devices. Many of these metals have industrially important uses in compounds and as pure metals. Let's look at some specific examples of where these metals are used in catalysts, alloys, batteries, magnets, compounds, and as pure metals. Vanadium is used in the V2O5 catalyst in the contact process, which produces sulfuric acid. Iron is used as a pure metal in the Haber-Bosch process, which generates gaseous ammonia. Iron is also used in the Fischer-Tropsch process. In this process, liquid hydrocarbon fuels are produced from carbon monoxide and hydrogen. And nickel is widely used in hydrogenation reactions. For example, in the conversion of benzene to cyclohexane. Now let's have a look at the use of these elements in alloys. The vast majority of alloys used are based on iron, in other words, steel alloys. This is because not only do iron alloys have useful properties such as strength, but iron is abundant in the Earth's crust. In fact, it's the most abundant metal of the first transition series. This is big business. Steels are covered in more depth in another video. Scandium, when alloyed with aluminum, results in a very hard, lightweight alloy. Some MiG fighter jet components are made using scandium aluminum alloys. Also used in aircraft as well as aerospace components are the titanium alloys. They are low in density but very strong. Vanadium and chromium, like scandium, add hardness to alloys. They are used in high-strength steels, for example in cutting tools and in axles. Copper and zinc are alloyed together in brass. Brass is widely used for plumbing components, for example, pipes and joints. Bronze is an alloy that uses copper, along with other metals like tin, aluminum, manganese, nickel, and zinc. Statues and medals are often made from bronze. We can see that these period 4 metals are highly useful when alloyed with other metals. They are perhaps more useful when alloyed. But some of them are used in their pure form. For example, copper. The vast majority of electrical wires are made from copper. Zinc is used to galvanize more reactive metals, for example, iron or steel. A thin layer of zinc is coated onto the steel. This protects the steel from exposure to oxygen and water vapor in the air, which would corrode it. Many steel structures can be galvanized, for example, ladders, steel palisade fencing, and balustrades. Chromium is also useful in its pure form. A thin layer of chromium or chromium alloy is electroplated onto a metal component to increase its corrosion resistance, hardness, as well as to make it really shiny. Motorcycle parts are sometimes chrome-plated, as well as some fancy wheel rims or mags. Let's move on to the use of these metals in batteries. Batteries or dry cells often contain zinc and manganese dioxide. You may have heard of alkaline batteries. These are conventional batteries. Rechargeable batteries, however, use nickel along with cadmium. Now, what about magnets? Magnets are surprisingly widely used, not just for posting pictures on your refrigerator. Period 4 metals are used in magnets for many devices. For example, in electric motors, transformers, generators, scrap metal salvage yards, microwave ovens, TV display devices, radios, and much more. Many magnets use iron in conjunction with a coil. When electricity flows through the coil, an electromagnet is produced. Iron is an integral part of this. Try and make your own electromagnet at home. You'll need an iron nail, copper wire, and a battery, which could be a zinc and magnesium dioxide battery. Can you see that most of the components of this system come from the first transition series? But besides electromagnets, we're probably all more familiar with iron as a permanent magnet. Well, cobalt also forms a permanent magnet along with samarium in samarium-cobalt magnets. These are powerful permanent magnets used in high-temperature applications, for example in aerospace components, in generators, sensors, and some medical devices. So far, we have seen the period 4 metals used as catalysts, in alloys, in batteries, as pure metals, and in magnets. The last category that we will look at is their use in various compounds. There are many important compounds containing these period 4 metals. For example, titanium in titanium dioxide is used in sunblock. The nanoparticles of titanium dioxide absorb some wavelengths of UV light. Manganese is found in the permanganate ion. This purple ion is a strong oxidizing agent and is used in many applications. For example, in water treatment to disinfect. Chromium in the orange dichromate ion is also used as an oxidizing agent, although it is not as strong an oxidizing agent as permanganate. Dichromate as well as chromate ions are used in pigments because of their strong color. Cobalt, specifically the cobalt-60 isotope, is used in cancer treatment. In cobalt therapy, the gamma rays from this radioactive isotope are directed towards tumors to kill them. Let's clear some space to look at a few more examples. Here is another use for chromium. Chromium in chrome alum and in chromium sulfate is used to tan leather. Chromium cross-links the collagen protein fibers in animal skins. In this way, the proteins in the skins are stabilized, and the skins become more tough and leathery. And lastly, copper in copper sulfate has some interesting uses. It acts as a herbicide, bactericide, and fungicide to control the proliferation of algae, bacteria, fungi, and even root growth in plants. Now that we've learnt about some of the many uses of the period 4 D-block metals, let's practice. Which of the following is one of the applications of scandium? A. Manufacturing of artificial joints. B. Leather tanning. C. Manufacturing of MiG fighter jets. D. Metal plating. Or E. Manufacturing of car springs. The question talks about the element scandium, or Sc. Scandium is found here on the periodic table. Specifically, it is the first element in the period 4 D-block elements. In other words, the first element of the first transition series. The first transition series metals shown here are very useful metals. They are economically and socially important. Now the question asks about one of the applications of scandium. When just a little bit of scandium is added to aluminum, the resulting alloy, which is lightweight because of the aluminum, becomes harder. The unique combination of being lightweight and hard is perfect for use in aircraft. Of the given answer options, the application of scandium is the manufacturing of MiG fighter jets, or rather some of their components. Artificial joints are commonly made from a variety of materials mixed together: ceramics, plastics, and metal. Titanium is the metal of choice in artificial joints because it is lightweight and strong and shows no toxic effect with human tissue, unlike some other metals. Leather tanning is achieved through the use of various compounds of chromium. The collagen proteins are cross-linked by the chromium, and this stabilizes the leather, giving it durability and a long lifespan. Many metals can be used in plating, but of the period 4 metals, chromium is the most common. In this application, a thin layer of chromium is electroplated onto other metal parts to create a hard, corrosion-resistant, and very shiny surface. We call this chrome. You may have seen some chrome-plated metal components on motorcycles. Car springs are typically made of steel. Steel is largely composed of iron along with some carbon. The combination of iron and carbon in steel give a very strong alloy, although very heavy. Steel would not be suitable to make MiG fighter jet components. Of the answer options, the application of scandium is manufacturing of MiG fighter jets or their components. Let's summarize what we've learnt about the period 4 metals. We learnt about some uses of the period 4 D-block metals, namely scandium, titanium, vanadium, chromium, manganese, iron, cobalt, nickel, copper, and zinc. We learned that these metals are very important, if not critical, to society and the economy, because they have so many applications in daily life and industry and generate so much money. Their applications include use as catalysts, for example, vanadium pentoxide in the contact process, use in many alloys, for example, copper and zinc in brass, use as pure metals, for example, copper in wires, use in batteries, for example, nickel in nickel-cadmium rechargeable batteries, use in magnets, for example, cobalt in samarium cobalt magnets, and iron in electromagnets, and lastly, use in a variety of important compounds. For example, manganese is used in the permanganate iron, which is used in water treatment to disinfect.